I'm working on recreating one of my favorite childhood games onto Roblox in an attempt to help me get better at Roblox game development. Just for practice, you know. This is where I ended last time. I made a grid and I added a walking system that lets you walk from one square to another. But the first thing I wanted to do was to make this look prettier because right now it's looking kind of rough. So this is the updated version, only took me about half an hour. What do you think? I think it looks a lot better personally. But now onto the real stuff. I need to add obstacles, aka squares that you can't walk on, or I don't know, it could be anything in the game, maybe like a wall or something just in the way. That was pretty easy though, even though it took me 40 minutes. As you can see, the ones that are blacked out don't let you walk on it, and everything seems to be working pretty well with the obstacles, except when I put my mouse right in this square right here, it crashes. And I have no idea why. What I ended up doing was changing the path so it calculates it from the ending point to the starting point instead of from the starting point. And now, all of a sudden, it works. Here, it crashes because it couldn't find a path, even though there was clearly one available. Up until this point, I was fixing the symptoms of the problems, but now I have to target the problem itself. Let me explain. If the starting point is right here, let's say the end goal is right here. The way my script works right now is you start at the starting point and check all the surrounding squares and decide, which one is closest to the end goal without getting further away. So right now, the closest one would be right here. And then it just repeats that process until it reaches the end goal. So the same thing for this one. Checks all the available squares that are adjacent to it and decides, hey, distance-wise, this is the closest one. And it keeps doing that. Which of these squares are the closest? This one. And then which of the ones closest? It ends up on it. However, what happens when the end goal is switched to be right here? Remember, it checks the surrounding ones to see which is closest, and it decides it's this one. Then it sees which one will bring me closer. As a human looking at it, you can see that the best path would be taking this step right here. But my script isn't as smart as you. You're really smart. You know that? All my script sees is I'm going this way when I need to be going this way. So it keeps trying to find a better route, a better route. It doesn't think that this is a way to get there. So that's why it keeps crashing. And yeah, I can fix the symptom of this, but to fix the actual problem, I'm going to have to implement a better pathfinding algorithm. Another problem I have with this pathfinding script that I made, even if there isn't a path available, like in this little island right here, it shouldn't crash. So that's something else I have to fix. Remember, I'm really new to all this pathfinding algorithm and stuff. I spent about 10 hours and 50 minutes on it. So I decided to use my thinking brain. I show it my function and it tell it to give me one that actually works and tell me what's wrong with it. I copy it and paste it right in. And look, everything actually works perfectly fine, just copying and pasting the straight up script that it gave me. I was actually really surprised. In situations where the script I made would crash or can't find a path, my thinking brain scripts works just fine. But that's not what this series is about. This series is about learning myself how to do things. So I deleted the function the AI gave me and tried to do it all on my own. So here's my version of it. The AI recommended me to use an A-star algorithm. And basically what this is an algorithm that uses how many steps you've taken and the distance to the end goal instead of just the distance to the end goal. That way it can find the best path. It's basically a way smarter version of what I was trying to do originally. I'll link some videos that teach it way better than I could, and that actually helped me a lot with this. I spent a lot of the time just trying to figure out how to make the pathfinding work. Here are my attempts at it. I spent hours just learning about the algorithm. I don't know why I struggled so much with this, but what I struggled with the most was implementing it into the scripting. I learned the algorithm pretty well, but I just had trouble putting it into the script, which I thought would be the easiest part since I have way more experience scripting than I do with pathfinding. But my real struggle was implementing it into the scripting, which was actually pretty surprising. But here are my attempts at it. The green represents the tiles that it's checking, and the orange represents the tile that it thinks is the best current path. This is showing you what happens when I try to make it go on a path that's impossible because obviously it can't get to that little square at the bottom right there. So it's just going to keep looking and keep looking. And that seems to work pretty well and not crashing. So that's something nice I fixed. Only took me 2 hours to get the script not to crash. Now let's see it with an actual possible path right here. And another one just to make sure it wasn't a fluke. So I tested out this a lot. Here's a few more examples of real time. And I fixed it to work pretty well after some time. Another thing I struggled with a lot too was sorting the final path because as you can see, there's a lot of orange squares that don't make it into the actual best path. So I was struggling with this a lot and I prayed about it and I ended up finding a solution soon after that. I don't know why I struggled with it so much. The solution was actually pretty easy. But we've all been there. We've all done silly little things. It takes up so much time. I know you guys can relate to this. Something I don't like about this, it takes the diagonal path. And that's because I didn't think it would matter if it takes a diagonal path instead of a straight path. But I guess it is right because the diagonal is further distance. So I had to fix that because I don't like it going diagonal like that. That looks bad. I did need help from the AI with that one line. Now it takes the straightest path possible. Perfect. I kept the function I originally had to make it look all nice and pretty, but now it's using the better pathfinding algorithm. And as you can see, it can traverse all these complex obstacles. My original one would have completely crashed, I'm pretty sure. This one is way better and I never run into any issues. And as you can see, when the path's not possible, it doesn't crash this time. All right, now let's test it in all sorts of different scenarios. Here's a 5x5 with one obstacle. As you can expect, it works pretty well. Here's a 10x10 with about a dozen obstacles. If the pathfinding looks a little glitchy, it's because I made it slower because we're going to get pretty crazy here. Here's a 25x25 with close to like 55 obstacles, I think. And here's a 50x50 with about 500 or so obstacles. And I'm sure this should be enough for you guys. You guys, this is enough chaos for you guys, right? I'm sure you're all satisfied. You're happy with this, right? You don't want any more, right? I'm just kidding. It's not you being slow, it's my computer. Here's 150 squares by 150 squares with 5,000 or so obstacles. And my computer can barely handle this. So we're not gonna go above 150 by 150. Let's just hope this works without crashing. I said we wouldn't go over 150 by 150. But what would happen if we add 18,000 obstacles? And yes, obviously I had to speed this all up for you because my computer was not having it. Alright, let's see what we're gonna get next time. Baseball. Interesting. It checks all the available squares that are adjacent to it. Outright.